Okay, so we're going to start with deriving the double angle identity for the sine of 2a. Now, the sine of 2a could be written as the sine of a plus a. Then, if we were going to use the formula for the addition of two angles in a trigonometric function, then we can do the sine. This is the sine of a. And remember, sine keeps the same sign, cosine cooperates, so that would be sine of a, cosine of a, then plus, because sine keeps the same sign, cosine a, sine a. Well, normally this would be like a, and this would be b, sine a, cosine b, plus cosine a, sine b. But now, since they're the same angle, then we just get the sine of a, cosine a, sine a. Well, then that is really the same thing. This is just flipped from that one. So we just get 2 sine a, cosine a. And that is the double angle identity. Next, we need to derive 3 double angle identities. 3 double angle identities for the cosine of 2a. Okay, so first we're going to use the same idea and logic as we did up there. We're just going to do it for cosine. So that's the cosine of a plus a equals, and then remember that the cosine cooperates, so that's the cosine of a, cosine of a. So that's like angle A and angle B. And then sine keeps the same sign, so we're going to change this to a minus, and then it becomes sine A, and then sine B, but B is A. So sine A. Well, this is, just since these are the same angle, you can put those together and write that as the cosine squared A minus sine squared A. That doesn't look very much like a squared. Looks like a cubed. Alright. Sine squared A. Okay, so that's one formula. Now, if we were going to use the trigonometric identities, we could write that. Let me try to fix that. There we go. Okay, so we could replace cosine squared with something, or we could replace sine squared with something. So that's going to give us our other 2 trigonometric identities for the cosine of 2a. Because cosine turns out to be squared, that's why it has 3 of them. This one, right here, and then 2 more. This one only has 1 because there are no squares in it, and so we're just left with the fundamentals, sine and cosine. All right, so let's continue with the cosine, starting with this one, and we're going to use the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So we're just going to remember that, and we're going to solve it for whichever trigonometric function we need. So first I'm going to replace cosine with 1 minus sine squared. So that'll give me 1 minus sine squared A. That's the cosine squared minus sine squared A. So now this gives me 1 minus 2 sine squared A. That's the second trigonometric identity. Lastly, if we start back from this one and replace sine squared now with cosine squared, then we get cosine squared A minus 1 minus sine squared A. Oops, just kidding. that means sine squared. Sine squared is what we're replacing with 1 minus cosine squared A. There we go. Well, then now you just distribute your negative, and we get cosine squared A minus 1 minus a negative, so plus cosine squared A. Well, then that'll give us 2 cosine squared A minus 1. Okay, so that completes our double angle identities, which you see right here. You need to memorize all 3 of the cosine ones, and as well as the sine one. And then here's the tangent one, and again, like we've talked about before, you can memorize the tangent one, or you can use that it's the sine of 2a over the cosine of 2a. Most students find it's easiest to memorize it, so I would recommend it, but it's not absolute. You don't have to. Now, which cosine one to use all depends on what you're doing. If you're trying to get to just sines on the other side of an identity that you're verifying, then you would obviously want to use this one. If you want to only have cosines on the other side, then you would use this one. So it really just depends. I have this one. This one's the one I use most, and then I just replace to get one of these or get one of these because I don't like memorizing. So I just have this one memorized and this one, and then I replace like we just did up there. Basically, I prove them every time. Most students don't like that though, and they would rather just memorize all 3. So that is entirely up to you. Okay, so now we're going to use the identities because they want us to find the sine of 2 theta and the cosine of 2 theta and the tangent of 2 theta. Now, you cannot just double the cosine of theta and get that is 6/5, and that would be the cosine of 2 theta. That is not true whatsoever. You have to use an identity. Whenever you touch the inside of a trigonometric function, then you must use an identity. This is in the inside, and so it is blocked by an identity. Alright, so never ever just double something or add 2 things together. Just like there's no distributive property, there's no doubling or multiplying just by 2. You have to use an identity. Okay, so first of all, we're going to use that the cosine of theta is 3/5, and the sine of theta is negative. So if we just come over here and write our all students take calculus, then we can think of where is the sign negative. So sine is negative. Well, it's positive here, so it's going to be negative right here and here. So if it's negative there, then what we're going to want to do is find where cosine is positive next. So cosine, because it's positive 3/5, so cosine is positive here and here. So that must mean that my triangle is in the 4th quadrant. So now I'm going to draw a triangle in the 4th quadrant. And I'm going to label it adjacent and hypotenuse. So then that's adjacent over hypotenuse, so that would have to be a -4. Alright, so, and that was using a squared plus b squared equals c squared. And that's how I found that 4. Okay, so, and then it was down, so I put a negative. So now I need the sine of 2 theta. Well, from the page before, or because you already have them memorized, because you're just so brilliant, the 2 sine theta cosine theta. Okay, so then I just use my formula. That's my triangle, and then the sine is opposite over hypotenuse, so -4/5. And then the cosine of theta is positive 3/5. So then I get 6 times 4, -24/25. That would be the sine of 2 theta. Okay, the cosine of 2 theta is is Well, it doesn't matter which one I use, so I'm just going to use the one I have memorized, which is cosine squared theta minus sine squared theta. Remember with this one, it is not plus. That would be the Pythagorean identity. And cosine comes first. I just remember that because it's cosine, so cosine comes first. So that is cosine squared is 3/5 squared minus, and then negative 4/5 squared. Okay, so then, let me just go down a little bit. So then we get 9/25 minus 16/25, and then 13, 14, 15, 7. Is that right? Everybody's here to confirm if that's right. So yes. Alright. So then I know I can do all that, and then it takes me a minute to subtract 9 minus 16. Okay, and then finally we can do the tangent of 2 theta. Now, if I want to come back to the page before, I can use the formula 2 tangent A over 1 minus tangent squared. Okay, so 2 tangent, 1 minus tangent squared. So let's do it that way first. So the tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. So that is 2, and then the tangent of theta is adjacent, opposite over adjacent, so negative 4/3 over 1 minus 16/9. And then I could figure that out and blah, blah, blah. Or I could do it with the sine of 2 theta over the cosine of 2 theta, which I've already figured those out, so I might as well just use those. Negative 24/25 over negative 7/25, and I get 24/7. Now notice, the sine of 2 theta is negative, the cosine of 2 theta is negative, and the tangent of 2 theta is positive, which must mean that 2 theta is in quadrant 3. Not that you had to know this, not that you had to answer this, but I just want to point out that it does not end up in the same quadrant as theta. Okay. Next, we're going to verify the identity. Notice there's some double angle identities in both sides of it, so when I go to do this, I have to decide if I want to work on which side. And remember, you can work on either side you want, as much as you want. Just make sure... Oops. That was terrible. Recording is in my way. Okay, I'm just not going to draw a straight line there. And just make sure that when you write a reason, that it matches all the way across. Otherwise, you need a new line. Okay, so this one. First, I'm going to do the double angle identity, and I'm going to do it for both of them on both sides, and then I don't need to use up 2 lines. Not that it matters. I'm saving paper. And I forgot the word angle. So double angle identity. Okay, so for this one, this would be the cotangent x times And then the sine is 2 sine x cosine x. On this side, it would be 1 plus. Now I got to choose which one I want. Well, this has got sines and cosines in it. But I'm going to think ahead, and cotangent is cosine over sine, so my sines are going to cancel. So I'm going to end up with all cosines. So I'm going to use the cosine one here. But if you didn't, well, actually, no, I'm not. I'm going to just do the one that I said that I always have memorized and then derive it from there. But if you followed that, feel free to just use the cosine one. Okay, so that one is, what, cosine squared x minus sine squared x. Okay, so back to this side. Now I'm going to turn this into cosine x over sine x times 2 sine x cosine x. Remember, these guys are in the numerator, so you're gonna be able to cancel those two right there, and that is the quotient identity. Okay, next those cancel, so I get 2 cosine squared x, and that's it for those. And that would just be simplification or division. I don't like the word simplification for it because everything has a reason that it's simplifying. Okay, so now next I want to get rid of the sine squared because I only have cosine squareds on the left side. So for this one, I'm going to write that as 1 plus cosine squared x, and then I'm going to use my Pythagorean identities and write that as 1 minus cosine squared x. And that is a Pythagorean identity, like I just said. And then I'm going to distribute the negative, so I get 1 plus cosine squared x minus 1 plus cosine squared x. And then my 1, oh, and that was just distributive property. Okay, and then next I am going to subtract my 1's and add those, so I just get 2 cosine squared x, and you could just write addition for that, even though technically you subtracted those 1's. Subtraction is addition, just addition of a negative, so we'll just call it addition. Alright, and then that's it, and then don't forget at the bottom your QED, or your box with a dot, whichever one, but I need to know when you think you're finished with your proof. Alright, there it is. Okay, next we're going to simplify. Simplifying an expression. It's difficult because you just don't know when you're done. I mean, when is it simple? I would say, well, definitely if you use your unit circle and get an answer like root 2 over 2 or something, then it's simplified, certainly. But I guess just when it's all condensed into one trigonometric function is another way to think of it as simplified. So anywho, let's just try it out. So this is cosine squared. Basically, they're just trying to say, hey, find an identity and use it. So if you see an identity and you use an identity, then you're probably simplifying it. So cosine squared of something minus sine squared of that same something. They have to be the same. This has to equal that one. So I'm just going to think of that as like my theta. Okay, well that equals, by the double angle identity, the cosine of 2 thetas, which is 2 7x's. Alright, well then that's going to be the cosine of 14x. Now you can't evaluate that or anything like that, so that's it. That's as far as you can go. Okay, now this one's actually got values in it, so we're probably going to be able to evaluate the theta, the sine of theta and the cosine of theta. All right, so again, these have to exactly match to use an identity because it's the sine of 2a and the cosine of 2a, so these are both like a. All right, so if this had a 2 here, then I would know the identity, but it doesn't have a 2 here. Well, that's the beautiful thing about math. If you want one, you just make it, and then you just undo what you just did. So that is a half, and then 2 sine of 15 cosine 15. See how I didn't really change it because 2 and a half cancel, and so it's really that again. So I kept at the integrity of this equal sign. However, now it looks a little bit like something I can use. So then that's a half, and then 2 sine theta cosine theta. Well, that's just the sine of 2 theta. So that's the sine of 2 times 15 degrees. And then that is a half sine of 30 degrees. And then 30 degrees is on your unit circle. That's right there. It's the short one. And so that's root 3 over 2, 1/2. So that's a half. And then the sine of 30 is what I just found over here. That's a half. So I get 1/4. And that's the answer. And obviously that's simplified as much as we can. All right. Write sine of 3x in terms of sine of x. Well, that's going to use a double angle identity, and then it's going to use one again because it's triple, and there is no triple angle identity. Okay, so the sine of 3x is going to be the sine of 2x plus x. We're basically just going to do like we just did when we proved the double angle identities. We're just going to now prove a triple angle identity. You don't have to memorize a triple angle identity. That would be crazy. We can derive them whenever we need them now. So this is the sine, actually it's using the, so we're going to use the addition formula. Sorry, so that was right. That is the sines keep the same sign, cosines cooperate. So it's the sine of 2x cosine x plus cosine 2x sine x. If you're not sure what I'm doing here, then this is a and this is b, and the sine of a plus b is sine a cosine b plus cosine a sine b. So that's what I'm using. And 2x is like a, so see, 2x. And then x is b, so see there's the x and there's the x. And they just kind of switch orders there. So next, I'm going to use the double angle identity for sine. So now I get 2 sine x cosine x. That's the double angle identity for sine. So I'm just going to put that in parentheses so you can follow it along. And then cosine x. Plus, now I'm going to use the double angle identity for cosines. Well, I've got 3 choices here, but it says that I want to write it in terms of sine of x, which means I'm going to choose the one with sine x. So if you can't remember it, then flip back now and take a look. I'll wait. And then go ahead and write down the cosine, the double angle cosine identity with just sines. So that's going to be 1 minus 2 sine squared x. And then sine of x. Alright, so then that's 2 sine of x cosine squared x plus, now I'm going to distribute that there and there, sine of x minus 2 sine cubed x. Alright, now I've just got one more issue, and that's this guy right here. but I can use a Pythagorean identity and write that as 2 sine x, and then 1 minus sine squared x plus sine of x minus 2 sine cubed x. There we go. Okay, well, I've technically done what they asked, which is right in terms of sine of x, but we're going to simplify it if possible. So that's going to distribute into there and there. So now I get 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. Alright, well then that is, what is that, 3? Oh, well let's actually write our highest degree first. So negative 4 sine cubed x plus 4 sine x. And there you go. So to write it in terms of sines, and we have. Alright, and as you can see, there would have been multiple ways we could go with this one. I could have chosen a different cosine of 2x, and then it all would have come out differently. So that's why we're not going to memorize a sine of 3x, because there are, once you get squares involved, then you have Pythagorean identity, which means you can change sines to cosines and cosines to sines as long as they're squared. So that's going to give you a lot of different options. So we're not going to memorize those. Okay, so to derive the identity for the sine of a over 2, so we're going to talk about half angle identities next. And to derive the identity for sine of a over 2, start with the following double angle identity for cosine and solve it for x. And solve for sine of x. Okay, so just solve this for sine of x now. So we're going to start with this one, the double angle identity for cosine, and then we're just going to solve it for the sine of x. So first I'm going to subtract 1 from both sides, and so that would give me the cosine of 2x, and I'm going to put that in parentheses, minus 1 equals negative 2 sine squared x, and then I'm going to divide by negative 2, and so then I get 1 minus cosine of 2x all over 2. Okay, so I didn't really do anything differently there. I just distributed a negative here and here, and that made that positive, so I wrote it in front, and then made that negative, so I wrote it afterwards to make it a minus sign. And then that gives me the sine squared of x. And then I'm going to take the square root of both sides, and then whenever you take the square root of a square, you know, you put plus or minus. So that's it. That's the half angle identity for the sine. So that's the sine of a over 2. Alright, now, let's talk about why mine looks different. Because, so now mine looks like this. It's actually the sine of x equals plus or minus the square root of 1 minus cosine 2x over 2. That looks different than this one here where I have an a and then an a over 2. Well, if a is 2x, then a over 2 is just x. See? So it's just saying whatever this is, double it. So a over 2 here, if you double it, you get a. So that's all the formula is saying, is that whatever you have as your input for the sine, double it, and then take the cosine of it in this side. Okay? So it's that's why it's the half angle formula, because this value right here is half of this one. All right, so let's see it in action. Everybody gets confused by this a over 2, and it is not the sine of a and then all divided by 2. This a over 2 is actually inside the sine. And again, you can't touch the inside of a trigonometric function without a formula or an identity. Okay, so find the exact value of the cosine of 15 degrees using a half angle identity. So I want to say why they say using a half angle identity. It's because a lot of times on your unit circle, the things that they want you to do half of, you could actually just use the subtraction and get, so like 45 minus 30. So you could do the cosine of 45 degrees minus 30 degrees. You could do that and use your subtraction, the sum and difference formula. So you'd get cosine 45, cosine 30, plus sine 45, sine 30, and then do that. Okay, and then this is what it says here, the difference of angles formula to find the cosine of 15. We found this. Once we're done with this one, if you use your calculator to approximate it, you'll see that they all come out the same. They're just going to look differently. Alright, so we're just going to use the half angle formula from right here for cosine. And remember, you just double it. So you can memorize these formulas pretty easily as well by, well, cosine is just a plus and sine is just a minus, and that's it. They're the same formula, but when they're the same, you get a plus, and when they're different, you put a minus. And then this is the formula. If you just look at this, this is the numerator of this one and the numerator of that one, which makes sense because tangent is sine over cosine. All right, so let's use the formula. We have the cosine of 15 degrees. Well, what over 2 is 15? I don't really like to write it as something over 2. Everybody gets confused. I just remember that whatever this is double it. So that's going to be plus or minus the square root of 1 plus the cosine of doubled, so that's 30, over 2. Now I have to decide if it's plus or minus. So you look back here and you think, all students take calculus. Now 15 degrees is in quadrant 1, so that means it's going to be positive. So then I get just the positive. I'm not going to use the negative anymore. 1 plus, and then the cosine of 30 degrees. That's here again, and so that's 1, 2, 3, and then 1/2. So root 3 over 2 over 2. So that gives me the square root of, okay, now I am going to get a common denominator, so that's 2 plus root 3 over 2 over 2 over 1. And then that flips and multiplies, so that's times 1/2. So then now I get a fourth. Well, the square root of a fourth is 1/2. So I get the square root of 2 plus root 3, and then over the square root of 4, which is 2. And you can leave it like that. Root under a root is completely fine. That's acceptable, simplified. In fact, you don't have to rationalize denominators anyway. You know, I always have to anyway. It's ground into me. But but I do expect you to simplify. The square root of 4 is 2. That's absolutely expected. You know the rules. No negative exponents, no fractions over fractions, which is why I had to do this. And no easily simplifiable things, which I consider the square root of 4 to be easily simplifiable. Okay, so if you had done this in your calculator, if you do the cosine of 15 in your calculator, and make sure you're in degree mode if you just put in the cosine of 15. So I'm going to make sure I'm in that, and then I'm going to do the cosine of 15, and I get the approximate value of the cosine of 15 is 0.9659. Now, if I put this in my calculator, the square root of, and then 2 plus, I hope you're doing this with me, the square root of 3. Make sure you put, if you're going to put this in your calculator, make sure you put parentheses around the whole thing and then this. Unless you have that operating system. Remember, if you have the operating system that gives you like the little box over the little box, then that's nice. That's alpha y equals is how you get that. Okay. And then that's super helpful, and it'll also give you the little box inside of the box when you do that, so you don't have to keep up with any of it. But if not, then you need to do it like this. So you're going to hit the square root, which automatically gives you this one, and then 2 plus, and then the square root, which is going to give you this one. So then you close that parenthesis, and then you close that parenthesis, divided by 2. Okay? And when you do that, you do get 0.9659. Then finally, if we do this one, then you're going to do the square root of, oops, no, first you're going to hit a parenthesis, then the square root. Let me start that again, because this one's going to be all kinds of parentheses on it. Okay, so you need parentheses on the top, then you're going to have parentheses here and parentheses here because your calculator just automatically gives them to you. So you have to deal with them. So we're going to put a parenthesis, and then we're going to have the square root, which automatically gives us 1, so we have to close that, plus, and then automatically gives us another one, so we have to close that, and then close the numerator parentheses, and then divide it by 4. Again, if you have the alpha y equals, then it's much easier. It makes your life much easier, and you can just put it in exactly how you see it. But I don't, so I'm going to do it. The square root of 6 plus the square root of 2. Close that parenthesis, then divide it by 4. And again, I get in 0.9659. So again, you can see any way that you do them. If you had done the difference of angles formula from 7.3, or if you do the half angle formula, or if you just put it straight in your calculator. But notice it is not half the, now I want to do over here, what is the cosine of 30 degrees? What's half the cosine of 30 degrees? Well, the cosine of 30 is root 3 over 2, so that's half root 3 over 2, or in other words, root 3 over 4. If you put root 3 over 4 in your calculator, then you get approximately 0.4330. Okay, so definitely not equal. Okay. So these two are not equal. Do not make them equal. Okay, add. So do not do this side. All right. So make sure you use a formula whenever you touch the inside of a trigonometric function. You cannot just half things on your unit circle or double them or any of those other kinds of things, or add and subtract them in any way, shape, or form without using a trigonometric identity. Okay. So let's find the exact value of the tangent of 22.5. Well, the 0.5 is going to be your clue that it's going to be a half angle formula. So if you double 22.5, then you get, what, 45? Okay, so that's not a bad one. But don't be tempted to just write that's 2 times 40, tangent of 45. So you have to use the half angle formula. So the tangent of 22.5 degrees is, alright, I'm going to use the plus or minus square root one that I know, so that's sine over cosine, so that's 1 minus the sine, and remember, it's just double whatever that is, so the sine of 45, over, and then cosine, so that's 1, oops, not sine, just kidding, I was thinking sine, but it is sine over cosine, but the formula for the cosine one is, for the sine one is 1 minus the cosine of 45, and then for cosine is 1 plus cosine of 45 degrees. So then we get, now I need to think about where is 22.5. That's again here, so it's going to be the positive one. So 22.5 is in quadrant 1, so I choose the positive one. So then that's going to be the square root of 1 minus root 2 over 2 over 1 plus root 2 over 2. Now you could have used any of those formulas you wanted. I just used this one. It's the only one I have memorized, so it's the one I'm stuck with. Alright, and then I'm going to get a common denominator. Well, that's just 2, so 2 minus root 2 over 2 over 2 plus root 2 over 2. So then now those have the common denominator. Well, if I flip and multiply, their denominators would just cancel. So I get the square root of 2 minus root 2 over 2 plus root 2. Okay, now it says you don't have to rationalize, but these are conjugates though, so if you did rationalize the denominator, then you would multiply by 2 minus root 2, which would give you that one, which would be a perfect square. So then those would cancel. But then you'd still have a radical in the denominator because you'd have the square root of it. But anyway, I would not consider that easily simplifiable. And the rules are no negative exponents. Good. No fractions over fractions. Good. And no easily simplifiable. Good. So that's good enough. Okay, so we have to now find, I'm just checking, see if this is the last, okay. So we now have to find the cosine, the half angles of cosine, sine, and tangent, given that the cosine of x is 2/3. And they're telling us in which quadrant x lives. So, this is just like a theta, right? So, and then 3 pi over 2 and 2 pi. 3 pi over 2 is straight down, 2 pi is over here with 0, so they're talking about quadrant 4. So I'm going to draw my triangle in quadrant 4. Oops, I probably need to change that to a pen first. Okay, now try that again. So I need to draw in quadrant 4. Wow, that was hideous. But whatever. Okay, so I need to draw that in quadrant 4, and then I'm going to label it. So that's the adjacent is 2. So that's adjacent over hypotenuse is 3. And then I'm going to use 9 equals 4 plus b squared. So that's 5 equals b squared. So that's negative root 5. Okay, so now I am going to find the cosine. Now this is x. This is angle x, not x over 2. But that's fine because they want me to find x over 2. So when I use the formula, it'll double and that'll give me x. So the cosine of x over 2 is positive or negative. Well, I'm not sure about that bit yet, but I can do the rest of it. Okay, the reason I'm not sure about that bit is because remember this is for x, and I want to know where is x over 2. That I'm not sure. As you've seen multiple times, just because an angle is in quadrant 4, the half angle doesn't have to be in quadrant 2 or something like that. You have to figure it out. Well, if you take this and half it, that is half of 2 pi, that is x over 2. So it'll tell you exactly where it is. So 3 pi over 4, and what is that? Pi. So between 3 pi over 4 and pi, where is that? Well, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi. So it's past the halfway mark of quadrant 2. But anyway, it's still in quadrant 2. So cosine is negative here, so I'm going to choose the negative. So please make sure that you consider x over 2 when you're doing it. Just like in the other ones, we considered whatever value was right here and found its quadrant, not the original's quadrant. Okay, so back to this. So we chose the negative, and then cosine is plus, so we get 1 plus the cosine of x over 2. All right, well, the cosine of x, so I'm going to leave my negative, and then the cosine of x is adjacent over hypotenuse, so that's plus 2/3, which I knew anyway because they gave it to me right there, over 2. And then no fractions over fractions, so that's negative square root of 3 plus 2 over 3 over 2 over 1. And that is negative square root of 5 over, now flip and multiply that, and I get 5 over 6. And that's fine. You don't need to rationalize it. It's not one of the 3 rules. So you're fine with that because it's not easily simplifiable. All right. Next, we're going to do the sine of 2x. I mean, x over 2. Sorry. Again, that's going to be plus or minus the square root. And I need to choose if it's plus or minus. Well, sine is positive there. So I'm going to choose the positive. And then 1 minus the cosine of x over 2. So then that gives me the positive, and then 1 minus, and then adjacent, 2/3, right? Over 2. And then we get the square root of 1, oops, not 1, sorry, getting a common denominator. So I need 3 minus 2 over 3. And then this is over 1, so I'm just going to flip and multiply. So then I get 3 minus 2, which is 1/6. And then I need to write that as 1 over root 6. And that's fine, or you can easily rationalize that one, so I'm going to. Or you could leave it like that, whichever one. All right, and then finally I need the tangent of x over 2. Well, that one is easier than using a formula even, because I just am going to do the sine of x over 2 over the cosine of x over 2. And that gives me root 6 over 6 over, now I'm actually gonna rationalize this one so that I can easily simplify it. So I can easily simplify this one, I mean. So then that's negative root 30 over 6, right? Just multiply by root 6 over root 6. Okay, so then I get negative root 30 over 6. Now my 6's cancel. And I get negative root 6 over root 30, which is negative 1 over root 5, which is negative root 5 over 5. Good thing, too, because I'm out of room. Okay. So that's it for that one. And you could also tell what quadrant x over 2 is in by these signs, but you already know what quadrant it's in because that's kind of going a loop-to-loop there. We already figured out the quadrant so we could figure out these signs. But you can check that there. The cosine is negative, the tangent is negative, and the sine is positive. Well, that's quadrant 2. All right. So now they want us to simplify each expression, and you know that with the square roots and whatnot, that's your hint that this is a double angle identity. Half angle identity. So remember, this is double of whatever is outside on this side. So that's going to be, and then plus, so that's got to be the cosine. And then this is doubled, so that's 6x. And that's it. I'm just asking you to go the other way with your identities, that's all. All right. 1 minus the cosine of 5a over, or that's an alpha, sorry. 1 minus the cosine of 5 alpha over the sine of 5 alpha. Well, I think that one is a tangent one. Let's go back and look at the formulas. There it is. 1 minus cosine A over sine A. So 1 minus cosine 5 alpha over sine of 5 alpha is going to be, so on this side, it's half of that. So that would be the tangent of 5 alpha over 2. That's it. Okie dokie. That is 7.4. I highly recommend that you try some of your homework now to see if you have any questions, since you weren't really able to ask me any questions on this. But anyway, if you have any questions, then please feel free to email me or ask them to me next time we see each other in class.